In this lecture, we start with some specific discussion on the TCP and the UDP protocols, what they are and how they work in the context of the TCP IP protocol suite. So, this is the first part of this lecture, TCP and UDP. Now, in this lecture, we shall be talking about the basic functionalities and roles of TCP and UDP. In particular, we shall be talking about something called port numbers and how they relate to data communication at the transport layer level and how TCP and UDP uses port numbers. Okay? These are the few things we shall be covering in this lecture. Now, we have already talked about the TCP IP protocol suite. Now, in TCP IP, if you look at the transport layer level, at the transport layer level there are two different protocols that are used. One is TCP, which is the short form for transmission control protocol, other is UDP, which is the short form for user datagram protocol. Now, the basic idea is whenever there is a user program, some program which is trying to send or receive data from some other host on the internet, it interacts with either the TCP or the UDP layer. Suppose I want to send a data, I can give my data to TCP, TCP in turn will give it to IP and IP will actually send or route the data via the data link layer which is below it. Okay. This is how it works. The user process, they will interact with either TCP or UDP and TCP and UDP will be using the IP layer which is below it at the network layer level. Now, this diagram shows what I have just now said diagrammatically. So, this is where we are at the transport layer level. So, at the transport layer level we have two alternatives, either TCP or UDP. So, whenever there is some user process which is running, there is a choice, it can either choose to use TCP or it can choose to use UDP. It depends on the application, what kind of facilities at the transport layer level the user process wants, and accordingly it can do that. But the point to note is that you see whatever you use TCP or UDP, at the network layer level you have no choice, you have this IP and only IP. So, both TCP and UDP, they interact with the IP protocol at the network layer level, which you recall is a datagram based service which is unreliable, datagrams might get lost, duplicates might get generated, order may not be maintained. These things I mentioned a number of times. Okay. Okay, fine. Let us now look at specifically what are the roles of TCP. What does the TCP protocol does? TCP provides a connection oriented service. It is reliable. Reliable means if there is any data corruption during transmission, some data packets are getting lost or gets corrupted, TCP is supposed to keep track of that, and if something is wrong, the source or the sender will be requested to again send the relevant part of the data, so that the receiver can receive the data in a correct way. That is reliability. Full duplex means it is a two-way communication. A can send to B, B is also sending some data back to A. So, it is not a one-way communication. Byte stream service means whenever some message is being transmitted, both the sender and receiver keeps track of how much data have been sent and how much data is yet to be sent in terms of the number of bytes. So, each byte has a number 1, 2, 3, 4, 5, 6, 7, 8 and both sender and the receiver keeps track of these byte numbers. How many bytes I have already sent, how many bytes I have not yet sent and similarly from the receiver it sends back sometimes some acknowledgement. It says that, well, I have received all bytes up to byte number 1050, you can now send me the bytes after that, something like that. Okay. So, to provide this end to end reliability that TCP provides, you see, because TCP provides reliability, the applications that use TCP does not have to care about anything. It assumes that my network is very reliable, there are no errors, everything that I send will be received correctly by the other end. But it is actually the TCP layer which handles all errors and tries to recover from the errors. Okay. Now, TCP provides this reliability using several mechanisms. There is a checksum where each packet is verified using a checksum mechanism whether the packet has become corrupt, whether there is an error in the packet or not. Positive acknowledgement. The receiver sends back some acknowledgement to the sender that, well, I have received all bytes up to 1050. This is a positive acknowledgement. So, now the sender knows I have to send byte number 1051 onwards now, rest have been received correctly. Timeouts. Well, if the sender sees that the acknowledgement is not coming from the receiver till some defined interval, there will be a timeout mechanism which will be enforced and the entire message or the segment will be resent. It will assume that there was some network error, maybe the data did not receive the other end, let me send it again. And end to end flow control. See, the speed of the sender and receiver may not be the same. So, dynamically both the sender and receiver, the TCP layer adjusts the speed of data transmission and data receiving, sending and receiving, so that the speed mismatch is taken care of. Well, now in addition to this, TCP also handles connection establishment and termination. Because it is a connection oriented service, similar to virtual circuits we talked about earlier, there is a concept of connection establishment and termination. But the thing to note is that you are talking about connection at the TCP layer level, but down below it is IP. Whatever you do at the TCP layer level, ultimately IP will be sending out datagrams, they will be following different paths and they will be reaching the destination in any other order. But the TCP layer gives an illusion to the user process that this is a connection oriented service. Okay? This is how it works. And TCP also, you see, because of the datagram at the IP layer, the data might reach the destination in some arbitrary order. TCP will put together all received data in the correct order, which is called sequencing, so that the user process at the receiving end will get the data in the correct order always. That is one of the main responsibilities of TCP, and this is what we mean by connection oriented. There is a virtual connection which is maintained and the user process assumes or means it gets a feeling that there is a connection and all data are coming through that connection in the same order. Okay. But actually TCP has to work quite hard in order to have all these features incorporated. Well, in contrast, UDP is very much similar to IP. It does not do much beyond that. It does not try to ensure any kind of reliability. It provides a connectionless kind of a service. It is a datagram service. TCP is a connection oriented, that is why some connection establishment and connection termination are required, but UDP does not require any connection establishment. Each packet is being sent independently, and because it is like a datagram service, this is also unreliable just like IP. Okay. There are just two additional things which are there in UDP which IP does not have. At the transport layer level, it incorporates a checksum to verify whether the UDP packet is correct or has been corrupted. If there is some corruption, there will be a checksum error possibly, and there is something called port numbers which are also added. Port numbers actually identify the user processes that are interacting with this UDP or TCP. We will talk about this. Yes. Now, you see, you think of a computer, you think of a particular computer on the internet. There can be several user programs which are running, P1, P2, P3, many user programs are running on this computer, and they may all be trying to communicate some data over the network. Over the network, it is sending and receiving some data. Okay. Suppose P1 has sent some data to somebody, and that somebody is again sending back a response, a packet is coming back. So, when the packet reaches this computer C, how will this computer know that this packet has to be sent to P1 and not P2? There has to be something in this packet, in the header, which must clearly identify that this packet has to be delivered to P1, and that is this port number. On each computer, every running process is identified with an unique port number, and whenever at the transport layer level a message is being transmitted either using TCP or UDP, in the header there is a port number, and that port number specifies which process is sending that message, and at the other end which process is supposed to receive that message. Those port numbers identify that. Okay? That is the role of port number, mechanism to uniquely identify the data packets associated with each process. So, each process will have a unique port number for every connection it is maintaining. Okay? So, as this diagram shows, diagrammatically we are illustrating same thing. Suppose on a particular computer there are 3 running processes, and when they are communicating over the internet, over the network, they will be assigned some port numbers. Let us say port number 10, 20 and 30. So, when process 1 is sending some data packet, when it is sending out some data packet, it will specify the source port number is 10. And when a response comes back, in the response the destination port number will be set as 10. So, that this computer will know that 10 is what? 10 is this process 1. This packet has to be delivered to process 1. So, this is how the transport layer in this computer will take care of sending and receiving of the packets and delivering them correctly to the appropriate application or process. Okay? This is how it works. Now, in TCP and UDP, these port numbers are 16-bit quantities. Well, 16 bits is quite large. You can have 2 to the power 16, which is about 65,000, 64K. You can have that many active connections, active processes running, okay? And this is quite large. And you see, there are certain applications which are well known. They are uniquely identified by some port numbers. Like you think of your mail, SMTP. SMTP will be having some particular port number. You think of some network application like Telnet. telnet will be having some unique port number. And if you think of any other kind of network application, the common ones will be having some unique port numbers. So, that suppose I am trying to send a mail, I know that is my mail server, I always know that my mail server will be working on port number so and so, port number 25 or something, whatever. So, whenever I want to send a packet to my mail server, that particular process, I will be sending a packet mentioning destination port number is equal to 25. So, it will always go to the mail server. Similarly, when I want to send some request to a web server, maybe the web server is working on port number 80, I will be sending a packet saying destination port number 80. So, my packet will automatically go to that web server and web server will process it and send the request back to me. So, by these unique port numbers, I can uniquely identify and contact a particular process which is running on the other end, right. Just one thing, let me tell you, well, in an internet scenario, if you think of a situation like this, this is a sender, this is a receiver. Well, often we talk about client server scenario. Let us say this is a client and this is a server. The client will be sending some request to the server. With respect to the request, this is the sender, this is the receiver. Now, when it sends a request, the client is supposed to know which process at the other end it is trying to contact to. So, the destination port number must be already known to the client. Okay. As I told you, for all the common applications, the destination port number is well defined, everyone knows about it. Okay. Let us look at it. This is the overall picture again I am showing. Here the MAC address or the hardware address we already mentioned earlier, this is a 48-bit address. At the IP layer, you have a 32-bit IP address. Now, at the TCP or UDP level, you have a 16-bit port number or port address. So, again just repeating, physical address ensures uniqueness of the network interface cards. Every network interface card you plug into your computer, that will be having a unique 48-bit address. At the IP address level, every computer you want to connect to the internet must have a unique 32-bit IP address. Every connection to the internet, to the router, to the network has to have a unique IP address. Port number or port address, every user process running on a computer must have a unique port address. These are the different levels of uniqueness that are maintained, so that process to process communication becomes very unambiguous and unique. Okay. Fine. Talking about this port number, I already mentioned this briefly. In a client server scenario I was talking about, there is a client who is sending a request to a server, it is wanting some service. What does the client need to know? The client need to know what is the IP address of the server, because it has to send an IP packet to the server, the request. So, the IP address is required, destination address. Not only that, it will also must know the corresponding port number of the application which I am trying to contact to. Well, I have given an example already. If it is a mail server which is running the SMTP protocol, I need to contact over port number 25. Okay. SMTP uses port number 25. If I am using file transfer, if I am using the protocol FTP, FTP uses port number 21. So, these are all so called well defined or well known port numbers. These are predefined. and these are some kind of standardized, everyone uses these numbers. Okay. Now, on each system, each computer, these port numbers, well defined port numbers and other port numbers that you may like to define yourself, they are stored in a particular file. If you want, you can have a look at them yourselves. Well, on any Unix or Linux system, there is a file which is located in under root under the etc directory. The name of the file is services. Well, under the Windows operating systems, various versions of Windows are there. Typically, under this path, there is also a file called services. Now, this file is a text file, it contains several lines of information. Every line contains something like this. It starts with the name of a service, it specifies the port number, a slash followed by a protocol, it can use either TCP or UDP, and there can be some optional comments at the end starting with a hash symbol. It explains what that service actually means, and there can be some aliases also, you can give some alternate names also. Well, here I am giving an example snapshot of a services file on one of the computers. This is shown. Well, here the font size is small, I am sure you may not be able to see it very clearly, but if you open that file I just mentioned, which is there on your own computer, you can see this file for yourself. Well, here I am just reading out some of the lines. There is a service called echo. It is running on port number 7 on TCP as well as UDP. So, if you send some message to the echo server, it will send back the same message back to you. Echo is used sometimes for the purpose of testing the communication. Okay, let us say daytime. Daytime is another service which is again running on port number 13 on both TCP UDP. If you send a request, day and time will be sent back to you. Then you see FTP, file transfer protocol, uses port number 21 under TCP. This is for FTP connection establishment, but when the actual data is being transferred, you use FTP data, and that uses port number 20 of TCP. Then Telnet. Telnet is used for remote login, it uses port number 23 of TCP. This SMTP uses port number 25 of TCP. Name server uses both TCP and UDP, port number 42. Okay. There are so many. TFTP, trivial FTP, uses port number 69 of UDP. And you see on the right, with this hash, some explanations are given. These are comment lines, and these are aliases. Some alternate names are also given, right. This is the typical format of the services file, which is there in each of the computers that are connected to the internet. It contains a list of all the active services and the corresponding port numbers and protocols that are used there. Now, there is something called ephemeral port numbers. Now, you imagine a situation like this. I am trying to contact a mail server, I know mail server's port number. So, I specify that as the destination port number and send it to that. But when the mail server sends back a response to me, how will I get the packet? Because on my computer there may be several user processes running. So, I must also be having some kind of port number, which I should tell the mail server as my source port, and when that packet comes back, that source port will become the destination port, so that it comes to me. But I do not have any unique port number, means what I mean to say, I do not have any well defined port number. I am using it for sending a particular mail only. These are called temporary port numbers, which I can request on a temporary basis, and these temporary port numbers are called something called ephemeral port numbers, right. So, here the same thing as I mentioned is explained here. These temporary port numbers are called ephemeral port numbers. So, whenever such a communication is initiated by a client, the sender's port number is some kind of random or temporary port number which is assigned. So, after that communication is over, that is again discarded, right. This port number will not appear on that services file. Okay. Now, there are some conventions which are followed. Port numbers starting from 1 up to 1023 are supposed to be reserved for the well known ports, but recently this has been extended up to 4095 as the number of such well known services are increasing, various kind of services are there, and numbers which are beyond 4095 and up to the maximum, they can be used as the temporary port numbers, the ephemeral port numbers, right. Okay. Now, talking about connection establishment, whenever under TCP IP, with TCP I want to establish a connection with another host, there are three things I mentioned already you need to specify. You need to specify the IP address, you need to specify which protocol you are using, TCP or UDP, and you need to specify the port numbers. So, whenever you specify all of these things, then only you can establish a connection. You see, for protocol, only for TCP the question of connection is coming, for UDP there is no connection, it is like a datagram service. Okay. So, you have to specify all these things, which are the IP addresses of the two ends, the protocol TCP, the port numbers at the two ends. If you tell all these things, then only you can say that you are in a position to establish a connection. And this kind of a connection, this information you are providing is sometimes referred to as an association. These 5 values, you specify the protocol you are using, local IP address, remote IP address, local port number which can be an ephemeral port number, and the remote port number. So, as an example, this can be an example of an association where you are using the protocol TCP IP, local IP address, local port number, remote IP address, remote port number. So, whenever you do some kind of a communication over the internet, this kind of association gets created automatically in the underlying networking software or the networking driver that is present. Okay. So, with this we come to the end of this lecture. In the lecture we shall be in the next lecture we shall be continuing with our discussion. We shall be looking at some of the more features of TCP and UDP. In particular, we have not yet seen the header formats of TCP and UDP. In particular, how TCP connections are made and terminated, and so on and so forth. These we shall be discussing in our next lecture. Thank you.